All right, hi everyone. Hopefully you're tuning in to check your work. Again, remember, try the work on your own, then come back to this and make sure you know how to do the stuff. Just watching this isn't going to help that much, but if you can follow along, check your work, and make corrections, then hopefully it can be valuable to you. Okay, so which player's scores are symmetric? I would look at player A. It's really close to symmetric here, but I would say it's a bit skewed to the left here. Right. And then player B, again, I would say skewed left. Player C, even though there's a lot of spread between the from Q3 to the maximum and from Q1 to the um, minimum, it's about the same. Each whisker is the same. So I would say player C is symmetrical. I never know if I spell that right. Player D, pretty close to symmetrical, maybe a slight right skew, slight right, but I would probably say player D is symmetrical as well. Um, which players are skewed to the left, like we just said, A and B. So I'm using this new function here. So let's see if when I skip to the next slide, if my writing stays. I hope it doesn't, but unfortunately it did it on the last review that I did. Okay, the writing stayed, but I should be able to, they added a new feature where I can erase it a lot quicker. That's good. Okay, so I'm erasing a lot quicker so that I can zoom out there a little and get back to the pen, which as we know, mightier than the sword. Okay, determine IQR for all four players. So again, IQR is Q3 minus Q1. So for each of these, I would say let's figure out where Q3 and Q1 here. I would say here it's 61 minus 55. So for player A, that is an IQR of 6. Player B, 64 minus 55. 64 minus 55, 9. Player C, 58 minus 55, 3. So that's the smallest one so far, which means it has the lowest variability. We know what to expect from player C. Player D, 55 for Q3, 55 minus 43 for Q1. 55 minus 43, that'd be 12. So player D, we don't know what to expect from player D because that's the highest IQR. That is the highest variability. So high variability, and player C has the lowest variability based on the IQR, which has more variability. So high is player D with a 12. That means we don't know what's going to happen, right? There's a big range of what we expect. And then after the lowest is player C, and then second lowest player A, and then player B. So the smaller the IQR, that means again, 50% of your scores are happening inside of that box, right? So the smaller the box, that means the more consistent you're being. More consistency, less variability. Okay. The transitions aren't as smooth as I'd like to, but I will work on this. This is a different technology than I had last year for recording these, so it's a bit of a work in progress. We've already progressed since I did this for Algebra 2 the other day. If you have any friends in Algebra 2, they'll tell you I was complaining about the new method here. The good thing is that because I have to upload this to YouTube, that if you like or subscribe it, it will actually let you know when the videos are ready, even before it's posted on the Schoology page. Otherwise, you can just go to the Schoology page and see this, which is where a lot of you are probably viewing this right now. Hello, all. Um, Where was I? But what you're missing out on is me joking about clicking a like and subscribe button when on our old thing there didn't actually it didn't exist. So students would say, "Hey, I clicked on that button, it didn't work." It's because it wasn't real. That was funny to me. Anyway, moving on. Any outliers in player A's scores? Now, at first glance, it looks like there aren't, but it doesn't matter necessarily what it looks like. But that's not all that matters, I should say. We need to actually calculate it. So we need to do Q3 minus Q1. Okay, so, which we really already did, right? Are these the same? Yeah, it's the same. 61 minus 55. So we got 6. Now to figure out if it's an outlier, remember, we need to do that number 6 times 1.5. 6 times 1.5 is 9. That number, we will take Q3 and we will add 9 to see if we have a high outlier. We'll take Q1 and we'll subtract 9 to see if we have any low outliers. Okay, are there any outliers in player in this score? Well, let's see. Q3, so that's 61 plus 9 is 70. Are there any scores 70 or above? No scores greater than or equal to 70. So no high outliers. Let's check on the other end. 55. Looks like we got some skew to the left, so maybe let's check. 55. That's Q3, Q1, I should say. 55 minus 9. That would be 46. 46 is anything below that is a low outlier. So yes, we have a low outlier because we know we have at least one score below 46. There's at least one below 46. And we can see that from this, our minimum being just under 43, probably at 42. Would the mean or median be a more accurate measure of center for player A? Now, mean and median both measure center. We're using a box plot, right? But it doesn't matter if the box plot is symmetrical, it doesn't really matter which one we pick. But when we have one that's skew, and especially if we have an outlier, and we have a low outlier here, that low outlier is really going to pull the mean, the average. It's going to pull it down more so than it will pull the median. So we want to use median. We want to use median because it is less impacted by outliers. We have outliers. Okay. Now, if we didn't have outliers, we could use average, mean, and standard deviation to help us. But because there are outliers and there's skew, then median and IQR are the way to go. You're gonna have to deal with me complaining. So on the old method, I didn't have to erase every time. I would just click the next slide, and the good thing about that too was I could go back to a question if I thought, hey, let's actually re-explore what we wrote there. So the bad thing here is not only does this take time, and time is money, people, but you can't use what we've previously written. All right, moving on. I'll switch colors just to see how that red works. It's a little too faint for me. Let's go with dark red. Any outliers in player C? Well, let's see. Player C had an IQR of 3, right? 3 times 1.5. Maybe that dot looks like a decimal, so maybe I'll just use a parentheses this time. 3 times 1.5 equal, what's half of 3? Half of 3 is 1.5. So 3 times 1.5 is 4.5. So 58, and that's Q3. 58 plus 4.5 equals 62.5. So anything above 62.5 is a high outlier. So yes, player C has high outliers. There's the work to show me. Don't just say yes or no. You have to actually prove it, right? This is the way you prove it. Yes, player C has how high outliers above 62.5. So I would mark, I don't know, 60 right around here. Everything above here would be a high outlier. And at first glance, because we know this was symmetrical data, right? So we know that whisker over there. I'm guessing that we're going to have a low outlier too. Let's do the math. 55 minus 4.5. That gives me 50.5. So anything lower than that, 50.5. We'll say it's right about there. So all of these, and it might just be one. We just know there's at least one. We know that these are low outliers. So yes, player C has low outliers. Also, why is mean a measure? Why is mean a better measure? Typical scores for player C. We have symmetrical data. Even though we have outliers here, we have outliers on both sides, but because it's symmetrical data, we can look at the average. We can look at the average here and it's not going to be skewed. Okay. So with, and if you notice, I'm spelling symmetrical different again. I didn't even check. I believe that's how you spell it. With symmetrical data, mean, and I'm just writing SD for standard deviation. Mean and SD are good measures of center, measure of center being mean, and as standard deviation being variability. Yep. And hopefully you're pausing, Ron. If I'm talking fast, pause, make everything. You can make me go slow if you need to, or you can also speed me up if you're like, I know all this. Did you circle and star a bunch of stuff in class? Hopefully you did. Most of you did. I saw you do it. As long as you're circling and starring this data. Oh no, it looks like some of the images didn't transfer over. That's not good, but we'll make the best of it. So, they're catching up. As soon as I erased, some stuff started showing up. Oh, I wonder how it looks on your end. On my end, there are images popping up. There are images popping up as I erase. And I'm wondering if that has to do with my erasing or if some things are just taking a while to load due to the recording. Regardless, we move onward. All right, so putting these numbers in order. So honestly, what I would do in this case, if I have to put numbers in order, I would actually start with the dot plot. It's really easy for me to lose track of what number I'm on. But if I go dot plot first, a dot plot puts numbers in order. Okay. A dot plot puts numbers in order. So 10, 8, 9, 10. If I put a dot there, 13, another 13. So what this dot plot is doing for me is doing me the favor of putting these numbers in order because it's really easy to mess up two tens, especially if you start trying to go faster. Okay, just double checking that 8, 9, 10. I'm at 10. I have two more. That's my third 10. 12, a 9. So the benefit of writing it in order is maybe you could do all the 9s at once or all these 11s at once. But I lose track of numbers when I go through these lists personally. So you really have to figure out what method works best for you. 12, 13, 14. But this gets me in order. There's another 12. I feel like I missed the 12 somewhere. 1, 2. I just did the third one. So yeah, I should have a third 12. See, there's no perfect system. 8, because there's no perfect teacher or student. 15. Got a 16, because then I'll say numbers and then mark them off, but not actually put them on there. 14, 12, 13, 14. That's my second 14. And my last 11. Okay, so if I'm looking at my dot plot and writing these numbers in order, I see that I have 1 8, 2 9s, 3 10s, 1, 2, 3, 4, 5 11s. 5, okay. 5 11s, 3 12s, 2 13s, a 2 13s, 2 14s, 15 and a 16. Okay, so I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I screwed up because I know there's 19 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, so I screwed up somewhere. Where is it? Where did I screw up? I'm guessing I either put too many 11s or too many 12s. Let me see. Let's count the 11s. 1, 2, 3, 4. All right, I'm double counting. 1. Yeah, I think I should only have 4 11s there. All right, so let's see if this eraser is worth the money that I didn't pay for it. All right, I think I corrected it there and correct it here as well. All right. So if you were screaming at the screen and ready to make a comment, ready to shoot me an email, hopefully I caught that thing that was screwing us up. Okay. Now that I have all these numbers in order, it should make my 5-number summary easier. My minimum is 8. My maximum is 16. My median, I have 19 numbers here. That's why I was making sure that I had the right number. Because with 19 numbers, 9.5 is half of 19. So what I'll do is count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that next number is my median. That's like the 9.5 because I should have 9 on one side and then 1, 2, 3, 4, 5, 6, 7, 8, 9 on the other. And I do. So there's 11. And it matters which 11. Okay. So there's that median. And then to find the quartile 1, I need to find the median of the first half of data. So I have 9 numbers on the left of the median. So half of 9 is 4.5. So I would go 1, 2, 3, 4. This 10 is my quartile 1 because I now have 1, 2, 3, 4. A good question someone asked me is like, do you count The median in this case is a number. No, not when you have odd numbers like that. Okay, so 10 and then quartile 3, 1, 2, 3, 4. Do the same thing. 1, 2, 3, 4, and it should split each half into half. So this would be like literally the first quarter, second quarter, the third quarter, the fourth quarter, the end of the game. The box plot just takes that 5-number summary, draw a line for each number you just marked, 8, 9, 10, 11, 13, and 16. Whiskers on the end and a box around the median. Okay, whiskers, box, whiskers with the median in the middle. All right, the shape of the data. Get my own picture out of the way. I would say, look at that. I mean, it's not perfect, but it's symmetrical. I would call it bell-shaped. Bell-shaped, symmetrical. I'm going to go with 2 M's this time. What measure of center is appropriate for this data set? I would go with a mean because it's symmetrical. The thing is when it's symmetrical like this, the mean and the median are going to be pretty close anyway, but mean works. The measure of variability, we would say the standard deviation. You don't have to calculate standard deviation on any of the problems on this test. We just need to know when to use the standard deviation and what exactly it is, not the actual calculation. So the standard deviation, and because the data is symmetrical, that standard deviation will tell us how far from the middle we tend to go off. I think the last slide coming up, if I'm not mistaken. Oh, don't cry because it's over. Smile because it happened. Eraser, 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 eraser. Make me a match. Find me a match. Sweeping eraser. Magic. I know you guys aren't as amazed by technology as perhaps I am, but the fact that I can do this is a marvel. All right. How many total students are in this class? So this is where you would have to use this histogram to check out. We didn't label it here. Maybe we should have the frequency data. Frequency, right? So between 0 or in between here, we have 3 occurrences of this right here. Okay. And this data right here, there is 7, and then 7 here, and then 7 students, not 7, 4 right here. This next, so right, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, that so on. So all of these occurrences, and you're not going to get half an occurrence. You need to add the frequencies to figure out how many students there are. I lost my train. There we go. 2, 1, 1. Okay. So to figure out how many students are in the class, we need to add these numbers up. 3 plus 7, that's 10, 17, 21, 30, 32, 33, 34. How did I get those? I added up 3 plus 7 plus 7 plus 4 plus 9 plus 2 plus 1 plus 1. If I screwed up, let me know. What is the median amount of money spent per student in lunch? Okay, so the median, so here's 2, here's 4. We would say that 2.25, 250, or sorry, 2.5, $3. So this would be $3.50. That's the median. That line is the median. So the median spent on lunch is $3.50. Are there any outliers in the class for typical amount of money spent on lunch? It looks like right here, the 10, or it's close to 10, right? I'm just going to go ahead and round up and say that it's about 10. Hey, it looks like that is an outlier, but we need to actually calculate if it is. Okay. And I'll even round up here. We'll say that we'll even round up for Q3. We'll say that Q3 is 5 exactly. We'll say that Q1, we're even making this lower than it would be because I got inexact data, but I'll just say that this is 2 for Q1. Okay, so 5 minus 2 is 3. 3 times 1.5. Gosh, we've had this calculation quite a bit, right? 3 times 1.5. Ironically, 3 times 1.5 the same as 3 plus 1.5. 4.5. Okay, so if we take 5 and we add 4.5, we get 9.5. Okay, I can't tell if this is exactly 10. I don't know if it's where it is above 9.5, but I can see that it's above 9.5. Okay, so is there an outlier? Yes. There's a student, at least one student, or no, we know it is one student. One student spends more than 950. Let's see, low outliers. 2, well, we can already tell. 2 minus 4.5, that would be negative. That means someone, I don't know what that would mean, that someone gains money at lunch, makes money at lunch, right? That, regardless of what it means, it doesn't make sense in this scenario. One student spends more than 9.5. It's worth noting that a low outlier is not possible. So we can't have negative money spent. Okay. Which measure of center should the teacher use to determine the typical amount spent on lunch? Why? We should use the median. Why should we use the median? Because with this data, with that outlier, median, because the outlier will impact the mean more than median. Okay, so that's similar to the example we were talking about with LeBron James, right? A lot of money. We don't use his income to determine the average income in Akron, Ohio. We use median, where it's going to eliminate that guy who makes close to $100 million or whatever he makes, this absurd amount, right? Something that isn't really an indicator of what usually happens. We take out the outliers, and median helps to kind of lessen the impact of those high and low outliers. Okay, that is all for the video. Wednesday is your test. No notes are allowed on the test, but as long as you finish the review and you practice, there should be no surprises on the test. You will do great. Good luck. Let's see if I can stop the recording. Bye.